Hello and welcome to our lesson on measures of dispersion. So measures of dispersion are basically two different ways that we can measure the spread of a set of data. Measures of dispersion measure the spread of the data. So far we've talked about ways to collect data for statistical purposes. We can survey, experiment, or do an observational study. We talked about ways that once that data is collected, we could organize it, into a circle graph, histogram, frequency polygon, frequency distribution. And then in the previous topic, we talked about one of the ways to analyze data. One of the ways to analyze data was to calculate measures of central tendency. We talked about 4 different ways that we could measure the center of a set of data. But sometimes that measurement isn't enough information, especially if we're looking at an actual situation and not just data for the sake of looking at data. Okay, so measures of dispersion are sometimes needed in addition to the measures of central tendency to make informed decisions. Okay, let me show you an example of what I'm talking about. Let's say you are looking at buying a new electric car. Okay, and there's new technology out, and company A is advertising their model, which is the one, or size, family sedan, whatever you're in the market for, that their car can go on average 1,000 miles before needing a charge. And then there's company B, and they have a family sedan in the same class, so it's got all the features you like, it's comparable. These are the 2 options you're looking at. But for company B, their car lasts on average, or can go on average, 950 miles before needing a charge. If that was the only information that you knew about the length or the distance the car could go before needing a charge, aside from all the other features, let's say all the other features of the cars are the same. Okay, if that was the only distinguishing factor, and you knew the average number of miles before needing a charge for company A was 1,000 and B was 950, which car do you think you would choose? And let's assume they were even the same price. Okay, if this was the deciding factor, well, it's likely that you would choose company A because you can go another 50 miles before needing a charge. Now maybe not, but based on that information alone, it seems reasonable to say company A, right? Now let me give you a little more information. Let's say company A, their average was 1,000 because half of the cars lasted 500 miles before needing a charge, and the other half of the cars lasted 1,500 miles before needing a charge. And when we averaged those out, right in the middle of 5 and 1,500 gave us that 1,000. Okay? Well, that's a pretty big spread. So even though there's an average of 1,000, you've got a 50-50 shot of either only lasting 500 or lasting 1,500. Okay? And then let's say for company B, their average was 950 because half of their cars lasted 925 miles, and the other half of their cars lasted 975 miles. So again, a 50-50 shot of either being at 925 or 975 to put that average at 950. So if I give you this additional information, do you think you're still going to choose the car from company A? Well, I guess if you're a bit of a gambler, you might still choose company A. But if I was going to choose, I would take the safer bet. Even though there's a chance you could get one of the cars that goes 1,500 miles, there's also the chance you get one that only lasts 500, and that's a pretty big difference. Whereas if you go with company B, the range is smaller there. Okay, the range is smaller, and that is important to know. So what we have are 2 ways where we can decide based on the average if the data is really spread out and if it's really far away from the mean, or is the data really close together and really close to the mean. So there are 2 ways to measure these the spread, what we call, of the data, these measures of dispersion. One of them is the range, and that's where we just take the highest and subtract the lowest. So 1,500 minus the 500 is a range of 1,000 here. There's 1,000 different options. And here, the range 975 minus the 925 is 50. There's only a 50-mile difference between the cars with company B, but there's a 1,000-mile difference between the cars in company A. That's important to know, okay? also important to know is how close all the data pieces are to the mean. So when I said the average was 1,000, that sounded good, but these values were really far from that 1,000. That would tell us that something called the standard deviation, that's the second measure of dispersion, the standard deviation is really big because these numbers are far from the mean. And in company B, the 925 and the 975, those are pretty close to the mean. So this would be a smaller standard deviation. Standard deviation would be smaller here, and it would be larger here because these are farther from the mean, and over in company B, they're closer to the mean. So those two calculations, standard deviation and range, are going to be helpful additions to our measures of central tendency. Okay, so going back to our note sheet here, again, measures of dispersion are measuring the spread of the data. So there are two types. There's, again, the range, and the range is just a simple highest value minus the lowest value. We just subtract those and see that there's a 1,000-mile difference or a 25-mile difference, okay? And then there's one called the standard deviation. The standard deviation is telling you how much each piece of data varies from the mean. How does it vary from the mean? Is it far from the mean? Is it close to the mean? And a smaller standard deviation implies that your values are closer to the mean, while a larger standard deviation implies the values are farther from the mean. Okay? So before we get into some calculations, I want to just give you a kind of a big picture again about how this standard deviation works, okay? So here's another example like the electric car one I mentioned a second ago. Let's say that Costco is in the market for a new line of tires to sell to its members. And you know Costco, if you've ever been a member, they try to get you good deals, okay? So we've got Michelin. They're offering a new tire that lasts an average of 35,000 miles. But the standard deviation for tested Michelin tires is 10,000 miles. Now Goodyear, they're offering the same style of tire, but it lasts an average of 30,000 miles with a standard deviation of 5,000 miles. Based on the data, which tire is a safer buy for Costco and its members? So let's see. Let's look at this here. Michelin tires. And then we have, what's the other? Goodyear tires. Sorry, my kid's distracting me. Okay, so it says for Michelin, let me highlight some Michelin facts here. Michelin's offering a new tire. This is the average is 35,000 miles. Okay, so Michelin average is 35,000 miles. And then when it says that the standard deviation is 10,000 miles, that means this is, again, a really general idea. On average, the number of miles that the tires will last is going to deviate by about 10,000. So it could be 10,000 above or 10,000 below. So the standard deviation of 10,000 we want to, so let me get back off my highlighter here, add and subtract 10,000 from this number. That means we're going to vary by 10,000. That means on average, our tires could be 10,000 miles below or 10,000 miles above. So let me just organize this a little bit better. We've got 35,000 for our average plus or minus 10,000. So that means these tires are going to last between 35,000 minus 10,000 would be between 25,000 and 35,000 plus the 10,000 would be 45,000. I just don't like how I'm organizing this here. I'm sorry. So these are going to, most tires last between 25,000 and 45,000 miles. Okay? Now Goodyear, so Goodyear, that's the one we're going to try to compare to. It says that the average is 30,000 and the standard deviation is 5,000. So they're going to be an average of 30,000. And if the standard deviation is 5,000, that means on average, these tires will deviate by 5,000 miles. So that means they could deviate up to 5,000 miles above or 5,000 miles below. And this is going to be most of the tires. Okay? So most tires last between, in this case, 30,000 minus 5,000 is going to be 25,000. And then 30,000 plus 5,000 is 35,000. And why did I choose to put a comma here and nowhere else? Guys, the things I do. Okay, so these are my options. Oops. And now, based off of these options, oh my goodness, caught the highlighter in there. Based on these options and the information we know about the average and the standard deviation, we have to try to decide which is going to be the safer buy for Costco. Sometimes it could be that a bigger standard deviation is better. Sometimes it could be worse. It just really depends on the situation. So here, if we look at the bottom end of both of these, so the low end of both of these is 25,000. Their low end is the same. But if you look at the high end of these, 45,000 and 35,000, the high end of the Michelin tires is better. So if most of the Goodyear tires and Michelin tires kind of bottom out at the same place, but the chance to last longer is better with Michelin, that is going to be a safer buy. So in this case, I would say Michelin, because of the fact that we laid out there, okay, if that makes sense. Again, this is big picture, and we're going to talk more about standard deviation and different distributions and what percentage of tires are actually going to last between, let's say, 25 and 35,000 miles. That's stuff we're going to get into, but this is just sort of big picture, okay? So now we're going to practice calculating the standard deviation, and this is a fun one. It's a toughie, okay, the calculation for standard deviation. This is the formula. So it says S, that's for standard deviation, is going to equal the square root of this little e is called a sigma. That means the sum of this is x minus x bar, where x is the data piece, and then x bar, that's a symbol for the mean. So what it's telling us to do in that section of the formula here, in this section of the formula, just in the parentheses, is saying take every piece of data and subtract it from the mean. It should make sense that we're going to do that because we want to know how far each data is from the mean. And then we're going to, this e means find the sum of all of those. Well, we actually have to square them first. So subtract each data from the mean, square the result, find the sum of all those things, and then divide it by n minus 1, where n is the number of data pieces. Okay? Now, the formula all by itself is already pretty darn complicated. In order to use the formula, we have lots of things going on, so we're going to try to fill in a table. We're going to list out the data in the first column, so the data is going to go here. We're going to calculate the mean, and it will be the same thing all the way down. And then we want to find the difference between the data and the mean, and that is that difference then is going to get squared, and then we're going to find the total of this whole column. So this last column, this total, that's what is going to be this part of the formula. Okay? So this last column, that total, is what goes into the formula technically. Okay? So we got to fill out all this stuff in the table, all this stuff in the table. All of this is just to get us to here, because that's the number that's going to go into the top part of that formula. Okay? Dots and squiggles everywhere. All right. So once we get that total, we're going to divide that total in that last column by n minus 1. So n, remember, that's the number of data pieces, number of data points, pieces, whatever. If we if there were like 6 values in the set, then 6 minus 1 would be 5, and that's what we're going to divide by here. So n minus 1, 1 less than the data, that's what goes in the bottom of that fraction. And then lastly, we're going to take the square root of that quotient. Square root of that quotient. So we find that total from the table. N minus 1 goes in the bottom of the fraction. We're going to divide those two things, and then the last step in the formula is to take the square root. Square root. Okay? So complicated. Let me walk you through it. Alright, so let's look at an example here. Luckily, you'll have this to reference. Okay, so we have this set of data. The mean's going to go into the table, so I want to start this process by calculating the mean. So I'm going to... I could put it in here and ask this to calculate for me, but I'm just going to add them and divide 7, 9, 11, 12, 15, and 18 is 72. And if we divide that whole sum by 1, 2, 3, 4, 5, 6, then we can see our mean is 12. Okay, so the mean is 12, and if there are 6 numbers, 6 data pieces, 6 values there, then down here I can just make a note that n is 6. That means that n minus 1, the part of the denominator of our fraction in there, is going to be 5. Okay, so 1 less is what's going to go into the formula. So our data pieces, that's what we're going to put in the first column. Data pieces are 7, 9, 11, 12, 15, and 18. The mean we just calculated was 12. So this is 12 all the way down. Now with this standard deviation, we're trying to determine if our values are all close to the mean or are they all far from the mean. So we're going to subtract the data from the mean. So if I take the data, subtract the mean, 7 minus 12, that's what we're doing here, 7 minus 12, that's going to get me negative 5 here. And then 9 minus 12 is going to be negative 3 here. 11 minus 12 is negative 1. 12 minus 12 is 0. 15 minus 12 is 3. 18 minus 12 is 6. And this I did not need. Okay, so notice that some of those are negative. Now, we're trying to figure out how far each data piece is from the mean. So these numbers are supposed to represent distance, but we don't want distance to be negative, and that's why in the formula you see those values getting squared. So in the next column we're going to take the data minus the mean that we just calculated and square it. So if we square negative 5, what's negative 5 times negative 5? It's going to give us a positive 25 here. Negative 3 times negative 3 is a positive 9 here. Negative 1 squared is going to be 1, 0 squared is 0, 3 squared is 9, and 6 squared is 36. So now what I need to go in my fraction is the total from this last column. So 25, 9, and 1, well that's 10, so that's 35. Let me just not goof. 25 plus the 9 plus the 1 plus the 0, we don't need to put in there, and then 36 is a total of 80. Okay, so 80, let me just correspond the colors here. That's total from the last column 80. That's going to be what we put here. And then n minus 1, that's what we got going here, that's 5. Okay, that 5, that's what we put here. And then we have to square root that. Okay, so we're looking at the square root of 80 over 5. And that is the square root of 80 divided by 5 happens to be 16, and the square root of 16 is 4. So our standard deviation is 4. That means on average, these numbers deviate by 4 units from the mean. So there's an average distance of 4 from the mean for every one of these data pieces. So that's one of the measures we need. The second measure we need to be able to calculate is the range. Luckily that one's pretty simple. For the range we're just subtracting highest value minus the lowest value. So the highest value was, let's see, 18, lowest value is 7. So the range is 18 minus 7. 18 minus 7, which is 11. So we have a range of 11 values, and those are the two measures of dispersion, again, that we need to be able to calculate. Okay? Now, great news. While it's some work that you should be able to do, organize into that table and make all those calculations, the calculator does it for you. Okay, I just wanted to expose you to some of that because, it's work that really you should be able to do. But the calculator will make the calculations for us. You don't have to really bother with making that whole table because Desmos does it. So just like we did the other day, or in the other topic, we're going to press the plus sign in Desmos, and that's going to give us a table where we can enter the data. And then in a new line from our functions menu, we're going to choose stats, and then we're going to look for standard. Let me see how it abbreviates here. I don't remember. Standard deviation. So it's go away, calculator. STDEV. That's our abbreviation for standard deviation. And then you want to tell it to find the standard deviation of list 1, which is going to be labeled X1. And then it's going to make the calculation for you. Okay? Now, we're going to practice doing all of the measures of central tendency, the quartiles, standard deviation, all of it. The only things the calculator is not going to do for you would be the mode and the mid-range and the range. But that's okay, because those ones we can do on our own. And actually, let's knock those guys out right now. So our values are 600, 100, 850, 350, 250, 140, and 300. I don't see anything occurring any more often than anything else, so there's no mode. Mid-range is the highest plus the lowest divided by 2. So in this case, let me just put that over here. This is highest plus the lowest divided by 2. So in this case, the highest is 850, and the lowest is 100, and then that gets divided by 2. So let's see, 950 divided by 2 is going to be what, 475? 950 divided by 2, 475. So 475 here. And let me just move this. And remember, this one is the one that the mode is the one that occurs the most, and there isn't anything occurring most here. And then the range is the other one the calculator's not going to do, but again, that's not so bad. Here we're going to take the highest and subtract the lowest. So the highest again was 850. 850 minus the lowest of 100 is going to make a 750-hour range. Okay, the other ones, although some of them are still reasonably easy to calculate, we're going to let the calculator do it. So we're going to hit the plus sign, make a table, and we're going to enter in our data. So 600, and then 100, and then 850, followed by 350, 250, 140, and lastly 300. Okay, so now I have my list in there. Now, mean, let's do that one first. We go to functions, we go to stats, I'm already there. I find the mean, and it says, what do you want to find the mean of? We want to find the mean of this list that we're labeling as X1. See X1 at the top of the list there? So we're going to type in X1, and it's going to tell me it's 370. So from the calculator, 370. Okay, and now let's go into another line, separate calculation here. Let's go median. So median of X1 is going to be 300. Quartile 1, let's go to a new line. Remember not to choose quantile, but quartile. And it's X1, and now we have to tell it which quartile. So we're going to put in a comma and say I want the first quartile by putting a 1 in there. So 140. And then quartile 2 is going to be 300. And then quartile 3 is going to be 600. And notice, notice here that these went too far. That quartile 2, remember quartile 2 and the median, they are the same number. Okay, the median and quartile 2, they are the same thing. Okay, and then the last one is the standard deviation, and that's the hardest one to calculate, so that's the one we're going to be happiest to let the calculator do. So not STDEVP, that's a standard deviation for a whole population. We're looking at just normal standard deviation of a sample. So STDEV, and then again of X1, and it's going to be 267.3-ish. So 267.3-ish. That's a pretty large standard deviation, which is implying that that these numbers could be really far from the mean, and in fact they are. So our mean is 370, but look at the variety of numbers we have in our list. Those numbers are pretty far. They stretch out quite a bit, most of them, from the mean. And that's what that standard deviation says. If it was smaller, we would see numbers that are closer to the mean. Okay? So that's that. Most of the heavy lifting the calculator is going to do. And again, we're going to talk more about standard deviation and different types of distribution. But you should have enough to get you going on the practice. But as always, if you find yourself struggling, then just reach out. I'm here to help. All right, guys, take care.